going to kind of start catching up to you guys. All right. So for this guy, what the fundamental theorem of calculus part 2 says is I can just focus all my attention at first on finding this guy's antiderivative. There's actually section 4.9, right? So this guy's antiderivative is, it's kind of nice because that 3's right there, right? It just goes back up. And I just want to, I'm going to show you a little bit of my own notation that I developed for myself, and you can use it or not later. Right now, this is like the standard way to do this. We've done the antiderivative, but I still need to evaluate it between -1 and 3. So that's just the way I represent. I've done the antiderivative, which is what this symbol means. I just haven't done these. So I put that right there, kind of to remind myself what to do. And why didn't I put a plus C? Yeah, it's a definite interval. You wouldn't be wrong to put it. It would just be a stupid extra step because the plus E's are going to cancel. I lock it. So when you plug a 3 in, you get 27 plus 3 is 30. Minus, when you put a -1 in, you get -1 minus 1, -2. So I get 32. And again, you could put 3x squared plus 1 into y1. You can do second calc number 7 from -1 to 3, and it should show you that 32. I lock it. Now, you know me. I'm going to try to keep trig alive for you. You could teach this whole course with very little trig, and that would just so screw you guys over. So I try not to do that. So what is this guy's antiderivative? That's what I focus on first. That's what this symbol here means. What is that guy's antiderivative? Where'd he come from? Tangent. So the better you know your derivatives, the easier antiderivatives are going to be. And I want to go from 0 to pi over 4. Notice real quick, this is a little thing, but in further math classes this could be important. And also, in case you get somebody even more tricky than me, these match, right? I'm taking the integral with respect to theta, and the function is of theta. Calc 3 is where you start doing multivariable, where you could do y squared dx or something insane, where they don't match. But right now they have to match for us to be able to do this. Now I just got to plug a pi over 4 in. What's tangent of pi over 4? 1. And what's tangent of 0? 0. So I just get 1. So the area under secant squared from 0 to pi over 4 is 1. That's kind of nice. All right, now here's a beautiful example of why the real rule for 1 over x is important. What is the antiderivative of 2 over x? Just take the 2 out of the way. So what's the antiderivative of 1 over x? Natural log of absolute value. And I have to evaluate it between these negative inputs. So that's why the absolute value is necessary. If the inputs were positive, I wouldn't even have to put the absolute value. So the 2 natural log of 1 minus 2 natural log of e. Is that cool? Put the top one in, minus, put the bottom one in. What's the natural log of 1? 0. It's the natural log of e. 1, so you just get -2. Makes sense it's negative because this type of function looks like this back here. Pretend like that didn't go through there. So any area between is going to be negative because it's under the x-axis. So if this was a flow rate, it would be a loss of water or cash or whatever it is that I'm flowing somewhere. I like it. Real quick, when I'm on this subject, what would be wrong if I would have made this integral this instead? Just one little change. What's the little change I made? I made one little change. Positive 1 instead of negative 1. This integral is not doable. Why? Beautiful. The function inside does not exist for something in this range. It's not defined for x equal to 0. It's what you call an improper integral. Some improper integrals you can actually do something with, and that would be in your future in, I don't think we do it in this class. I think it is Calc 2. You guys see that, though? You got to be a little careful because the book does make a point of this, and I think a couple of the homework problems might have something like this. So the first thing you really should do is make sure that this works for everything between those, or else the answer is quick. No can do. So that was fine. Didn't go across any freaky points. What's nice about this guy? Anything? What is the anything to the x had to come from itself? So start there. And what is the derivative of 3 to the x? Yeah, which is exactly what that is. So what's the antiderivative of 3 to the x ln 3? 3 to the freaking x. You guys semi with me? Let me do something while I'm talking about that. Here. Watch this. Oh, thank you. What do you got? Okay. Oh, I'm fine. I don't think I have any space on there anyway. Oh, I do. Sorry. I'm easily amused. Watch this. This is so cool. Help me out with this. What is the derivative of natural log of 4x cubed minus sine x? What is this guy's derivative? What's the derivative of ln of anything? 1 over that thing. Times derivative of the inside, which will be 12x squared minus cosine x. Is that cool? So then, this question is stupid easy now. What is the integral of this? What is the integral of this? That. Do you guys see that? What is the integral of this? That. Because the derivative of this is that. So integral is just another word for antiderivative. Does everybody see that? At this stage, we have to see that. If the derivative of this, then the integral of this is that. One is just undoing the other one. Right? And of course the plus c just to make that. But, now watch this. If I took this piece away and I just said, what's the integral of this? That is basically impossible for us right now. It's not generally impossible, but it's stupid hard. Because it's missing the chain rule piece that would make it come just from there. The answer to this can't be natural log of this because it's missing the chain rule piece. It can't be. Alright, so now I've got the antiderivative. Why is that the antiderivative? Because its derivative is this. Evaluate it between 2 and 3. So plug a 3 in there, you get 27. Plug a 2 in there, you get 9. So you get 18. Very nice. So what's the one thing you got to be careful about? This guy, he's almost beautiful. E comes from itself. But what do I have to take care of? Why is this not the answer? Because its derivative is not this. So what's the extra part that I have to kill? What is the derivative of e to the 3t? Yes, that times 3. So I better put this over 3 to kill the 3 that wants to come down. So then I do match. This derivative is this now. So now this is just an exercise in what do you do with something like this. E to the 3 ln 3 minus e to the 3 ln 2. What can you do with that? If you just stop there, I'm going to take points off. because I'm not evil. I just want you to be able to do basic simplification. And this is basic simplification. What's in the way? What do the E and the ln want to do to each other? They want to kill each other. If I could just get what out of the way, they'll kill each other. Stupid 3. Where do I put this? Somebody out there says, I'll tell you where to put it, John. Where do I put that 3? How do I get it out of the way? Well, put it back up in the power. Right? Just undo that property of log. Same thing with this 3. Put it back up in the power. What is e to the ln dies? E to the ln dies. So now I get 3 cubed minus 2 cubed. I get 27 minus 8 over 3, so I get 19 over 3. Done. Yay. So you have a base of E and a power with ln in it, there's got to be something you can do. They want to kill each other. Don't just stop there. Whew. So now the funny thing, this next part is actually easier than this in a way because I don't have to plug anything in. The only harder thing is I have to remember again to bring the plus c back in. These are indefinite integrals. Indefinite integration. Which means this. So what is the antiderivative of this? Where would it come from? Careful, that would be a derivative, right? Derivatives make the power go down. So integrals, antiderivatives make the power go up. Yes? Beautiful. Kick ass. Right? X to the negative 2. What's the rule? It becomes x to the n plus 1 divided by n plus 1. What's negative 2 plus 1? Negative 1. Divided by negative 1, so it just becomes negative. So this is where, trust me, my God, trust me. And if you don't trust me on anything, trust me with this. It's going to be really hard to shift gears between differentiation and integration. Your brain's going to do half of one and half of the other one at first. You're going to have to try to really separate those two processes. And if you get further in mathematics, in one problem you can do both of them several times. So your brain is going to go a little bit like, you can hear the gears grinding. Yes? Yes, ma'am?
Well, this might be a stupid question, but I rewrote negative x and negative 1 as negative 1 over x.
Beautiful.
That's okay?
That means the same thing.
Okay.
I love it. No problem with that from me. Kick ass. Now B, you should be used to this. It's not a trick. Pi is a constant, so what's the integral of pi dt? What would you differentiate to get pi with respect to t? Pi t. Plus c. So what's the integral of pi dw? Pi w plus c. Right? Same thing as the integral of negative 3 dx is negative 3x. Integral of pi dt is pi t. Okay. Oh, I forgot to say, well, the last 3 involved simplification. Hopefully you guys noticed that here. You can't integrate this without some simplification first. What is tangent? Sine over cosine. What's secant? So this is the integral of sine d theta. Because the over cosines cancel. And of course the integral of sine is what's missing? There it is. I just want to get somebody to say something. So remember, that's an example of grinding gears. Sine goes to cosine for derivatives, which means sine goes back to negative cosine for integration. It's the reverse. It's everything in the reverse. Ah. The first thing I have to do here is reduce all these. This would be x to the 7/3. So when I divide by x squared, I lose 2 x's, so that would be x to the 1/3 minus 4 over x plus 2 over x squared